Now let's look at spurious response. On the phase noise plot on the right there, at the very far end, we can see some spikes happening here. This is in fact coming from a complex system which has got a digital control loop, it's got some digital switching, it's got a processor running inside, and it's giving the user a lot of complex information about the state of the oscillator as it's running. All very useful stuff, but that digital switching noise does create a little bit of spikies on the phase noise plot. Where there are things we can do to try and move that away. So what we try and do as a design team is shift that to be outside the bandwidth for the phase jitter that we talked about before. And we can do that by slowing down the clock speed or putting in filters at specific areas. If we were going to specify that, we would probably have a spec that said something like spurious frequency of 80 dB C max, and that would be in reference to the main mode. So in this plot, the carrier frequency is 10 megahertz and 10 dBm, and we would specify that there would be at least 80 dBs between the carrier and the peak of whatever spurious noise was on the plot.